Hello, everyone. I'm Annie Ma Weaver, a partner manager with Google Cloud.
And I'm Shan Kondeve, a product manager with Google Cloud, coming to you live from our homes and basement. And thanks for taking the time to join us today for this virtual event.
We've got content organized in 3 sections. 1, why Google Cloud for high performance computing, or HPC. 2, some of our product capabilities that support HPC. And 3, highlighting some of our awesome partners that work with us to make our customers successful. If there's one thing that we want you to walk away with, it's that Google Cloud democratizes HPC, and we want to enable HPC the Google way through our partnerships and product portfolio. Let's start with HPC for Google Cloud. We want to share some real-world examples of HPC in action and how GCP is contributing. One of the topics that is top of mind for us and for many of us is COVID-19 and the scientific research being performed to develop diagnostic tools and a possible vaccine. A number of different scientific efforts are underway. There are teams working on discovering new drugs for treating COVID-19 patients. Others are focused on genomics, developing better techniques for genetic screening. There are teams that are running molecular simulations to better understand how the virus impacts human cells and the effects various treatments can have. All of these problems are HPC problems, where you have to perform large numbers of computations, and in some, there's also a large amount of data involved, making HPC even more critical for completing these workloads in a timely manner. Google has joined hands with industry partners to create the COVID-19 HPC Consortium. This consortium has gathered now more than 60 projects with hundreds of petaflops, millions of CPU cores, and tens of thousands of GPUs dedicated to COVID-19 research. In some sense, applying HPC to such research problems is not new. However, what is new is that this is an unprecedented situation, one that requires rapid response and unfettered collaboration across research groups drawn from academia and industry. Depending on the scenarios, researchers need access to new technologies. In some cases, accelerators like GPUs and TPUs, so that they can run their simulations and machine learning models faster. In other cases, they need access to new software. Last but not least, given the experimentation-driven nature of the research, users need on-demand access to resources since they don't know which project is going to lead to success, and they need the ability to adeptly allocate resources as needed. How do you overcome these challenges? We believe cloud computing in general, and Google Cloud specifically, has solutions and tools to address them. Google Cloud is playing a small part, and I want to emphasize that Google Cloud's contribution pales in comparison to the efforts that researchers and other individuals are putting in. Nonetheless, Google Cloud is helping where we can. Let me tell you more about a specific COVID-19 project where we're playing a part. One team at Harvard Medical School is screening ultra-large libraries of chemical compounds to accelerate the drug discovery process. Using a grant of Google Research credits for the first protein target of interest, the team at Harvard built on the scalable processing of GCP and Slurm, a scheduler that Google Cloud supports, to run 80,000 cores at the same time, and to analyze more than 1 billion compounds in 5 days. Using GCP and Google credits to scale up its computations, the team is able to conduct ultra-large virtual screenings much faster than ever before. As of May 2020, the team has targeted 16 proteins with 40 target sites and run 35 billion docking instances using 750 million CPU hours. Next, my teammate Shen will share how Google Cloud helps other organizations facing similar HPC challenges.
You may be wondering how relevant these challenges that Annie talked about in the context of COVID research are relevant to you, your users, and organization. Now, whether you're a large organization with a significant HPC budget or a smaller startup that is just starting out, there are always projects where you and your users need to collaborate better. There are going to be cases where you want to experiment with new technologies so that you can bring new products to market much, much faster. And lastly, you always want to have the flexibility and ability to respond faster to changing business needs and do not want to be constrained by typical procurement cycles. In short, you want to be agile. What I see working with many customers is that many of these challenges are even more pronounced for customers from commercial and industrial background, more so than research institutions. That is primarily because their need for security controls is higher, and typical procurement policies are not designed with agility in mind. Just as Google Cloud is able to address these challenges for COVID researchers, it can help customers in mainstream industries as well. Let's look at some specifics. One of the biggest challenges customers face is the fairly rigid infrastructure that you deploy on premises. The chart in this slide is an illustration of the business impact of having a fixed infrastructure. When you have infrastructure with fixed capacity, there are going to be times when the infrastructure is underutilized. And more importantly, there are going to be times when the infrastructure is oversubscribed, which means some of your users are going to face extended wait times, which translates either into delayed products or the inability to respond quickly to new market needs. This is all in addition to the challenge of having an infrastructure that can quickly go out of date and not meet the needs of your users. We talked about how HPC infrastructure is deployed on premises and some of the challenges. With Google Cloud, you can address all of those challenges. First and foremost, you have access to elastic compute and storage, which means you get to provision the resources that are right-sized for your application, nothing more and nothing less. Second, you also get access to new technologies, be it new software technologies or new hardware platforms. A group in your organization may want to deploy GPUs for a new algorithm or a new application that they're developing. And with cloud, you're able to do that in an on-demand manner, whereas in on-premises, you'll have to wait multiple weeks or multiple months to deploy GPUs and then figure out who is going to go manage that infrastructure. Lastly, Google Cloud also makes data sharing with internal and external collaborators easy and secure. By having all of your data centrally collected and curated, you can effectively and securely share it with users that need to have access to it, but also you retain control. You're able to deprovision access when a user or a group of users don't need access to data anymore, or you can very quickly provision access when new users join your organization. A number of customers today use Google Cloud for those very same reasons. Customers across industries ranging from life sciences to financial services to chip design to weather modeling all use Google Cloud today. That is in addition to a number of research institutions that use Google Cloud today and get the benefits of a globally available, secure, scalable, and on-demand infrastructure. You can find details about these and other customers at cloud.google.com/customers. With that, let me pivot and talk a little bit about some of the products and services that are available to customers on our platform. The most critical aspect for HPC applications is having a highly reliable and scalable infrastructure that is delivered as an on-demand service. To that end, Google Cloud's infrastructure as a service products span the breadth and depth of what users need. Compute Engine, which is the virtual machines product in Google Cloud, provides flexible-sized virtual machines that start up in seconds, while also allowing for custom configuration of processor, memory, and persistent storage to best suit the needs of your applications. Compute Engine VMs also support Linux and Windows operating systems, thereby allowing you to move applications that need both Linux and Windows operating systems to Google Cloud. You have the flexibility to choose between Intel and AMD processors. You also get a choice of processors that are optimized for high clock speed and vertically scaling applications versus those that are optimized for scale-out applications. There are a number of sessions in the compute to the details of the Compute Engine virtual machines product. I'd highly recommend watching some of those. Engine is backed by Google Cloud's high-performance software-defined networking. The Compute Engine networking VMs between themselves as well as and the internet with high throughput, low latency networking. Similarly, Google Cloud offers an array of storage products ranging from object storage to file-based storage. We'll cover some of the details of the storage and networking products in the subsequent slides. There's one specific virtual machine type that I want to highlight, a new product that we launched last year. C2, or short for Computer Optimized Virtual Machines, is a new VM type that is optimized for HPC applications. It provides 3.8 gigahertz of sustained clock speed. It provides full transparency into the underlying server architecture, thereby enabling advanced performance tuning. It also supports up to 3 terabytes of local SSD for high-speed ephemeral storage and provides 32 Gbps of network throughput. C2 VMs also include a number of software features that HPC applications can take advantage of. For example, it supports NUMA-aware applications, which enables applications to further improve their performance by reducing memory access times. In order to better support HPC workloads, we also launched a capability that gives customers control over the physical placement of their virtual machines. When it comes to inter-node latency in a HPC cluster, laws of physics come into play. The further apart your nodes are, the more time it is going to take for packets to be exchanged between the nodes in your cluster. There are algorithms, often referred to as tightly coupled algorithms, that are very sensitive to this latency. As a result, we now give you the ability to set a policy that instructs our placement algorithms to place the virtual machines as close as possible. And in most cases, that is going to be within the same physical data center rack so that you get the lowest possible latency possible. One of the reasons customers want to move to cloud is so that they can optimize their spend and get the most value for their cloud spend. There are quite a few mechanisms available in Google Cloud that allows you to optimize your TCO, but I want to highlight a couple that really speak to the way that Google Cloud in general has been architected and engineered from ground up to give you the flexibility. The first are custom machine types, the ability to create virtual machines with the amount of CPU and memory that you need. While you may be familiar with predefined virtual machines that you may have used in a different cloud environment, which, by the way, is optimized for providers' efficiency rather than customers' TCO, in Google Cloud, by adjusting a slider, you can choose the amount of CPU and memory that you need. And Google Cloud is the only place where that is possible. Next, Google Cloud has a feature called sustained use discounts that automatically gives you bigger discounts the more you use your virtual machines. There is no custom policy that you need to set as a user. There is no subscription. There's no special flag that you need to activate it. Just use your virtual machines, and the more you use it, you get a bigger discount. These two capabilities are in addition to some of the other capabilities that you'll see elsewhere as well. Committed use discounts, which gives you a bigger discount if you commit for a longer duration of time. Preemptible VMs, which gives you up to 80% of discount, which is great for workloads that can tolerate failures. CPUs are great for a broad set of workloads. That's why we all use CPUs. However, there are algorithms that benefit from the massive amount of parallelism that accelerators such as GPUs offer. On Google Cloud, in addition to offering AMD and Intel CPUs, we provide NVIDIA GPUs that Annie will talk about in a little bit, and a custom design and built ASIC for machine learning called TPUs. On the one hand, GPUs enable graphics visualization and can also be used as general purpose computation units for speeding up your algorithms, including machine learning algorithms. On the other hand, TPUs, short for tensor processing units, are specifically designed for machine learning use cases in mind by Google and help accelerate the time to solution for AI and machine learning applications. Storage services are a critical part of cloud infrastructure and play a very important role for HPC applications. Google Cloud provides a breadth of storage options, some of it from Google and some of it from our partners such as DDN, NetApp, and Dell. Customers can deploy their choice to their HPC apps. They can deploy a scale-out file server using Cloud File Store. If they need a POSIX-compliant parallel file system, they can deploy Lustre file system that is provided by DDN and is available on our marketplace. Deploy storage volumes from NetApp or Amazon for scale-out network-attached storage. Now, in all of these cases, customers can use Google Cloud Storage for cost-efficient cold storage of data, irrespective of what storage system is in use in their HPC cluster. Finally, they can also use data transfer tools that are provided by Google to move data from their on-premises environment into Google Cloud Storage, and then use that as a staging ground to hydrate their HPC clusters. No infrastructure can be HPC ready without strong networking capabilities, particularly for tightly coupled applications. As I said earlier, the fully software-defined network that Google Cloud operates provides all the policy-driven controls that you would expect from a modern SDN, but at the same time provides raw performance that you need for your network performance-sensitive applications. Google Cloud currently supports up to 32 Gbps of VMs and up to 100 Gbps of throughput for GPUs. The software-defined network gives customers control over networking policies, such as firewall controls, a global VPC, and an architecture for multi-region applications. You can now run MPI applications in Google Cloud. We support both OpenMPI and Intel MPI applications. And in fact, we just recently published a set of optimization scripts and a guide for tuning your application on Google Cloud. You can find those tools in Google Cloud's GitHub project. With that, I want to be mindful of the time and hand it back over to Annie for her to talk about Google Cloud's partners and how they help you be successful on our platform.
Thanks, Jen, for that helpful and comprehensive discussion of how GCP enables HPC through our products. Next, let's talk about how our partnerships enable HPC workloads. A typical HPC workload has a few key components. Some of these are necessarily and best served by a cloud service provider like Google Cloud, such as pricing models, accelerators, and the fundamentals, compute, storage, networking, etc. Other layers of the stack are often domain-specific. Examples include applications, tools, libraries, and management platforms. It is not possible for Google alone to tackle the wide array of offerings and requirements that exist at these levels. We are able to provide complete end-to-end solutions for HPC thanks to our partners. Our partners, some of which I will cover in greater detail in the following slides, complement and complete our native stack. With their know-how and technology, we are able to deliver end-to-end solutions to enable our customers to quickly and easily run HPC workloads on GCP. The first partner I'd like to highlight is SchedMD, which has built the market-leading open-source scheduler, Slurm. Google Cloud teamed up with SchedMD to release a set of tools that make it easier to launch the Slurm workload manager on Compute Engine, and to expand your existing cluster dynamically when you need extra resources. This integration was built by the experts at SchedMD in accordance with Slurm best practices. Google Cloud is the only public cloud provider for which SchedMD has built these optimized Slurm scripts, thanks to our partnership. For those interested in trying out the scripts today, please scan the QR code on the slide to be redirected to a code lab that will teach you how to run a Slurm cluster on GCP. In March of this year, SchedMD released version 3 of the Slurm on GCP scripts, which are available on its GitHub page. Please visit the code lab, SchedMD's GitHub, and reach out to your cloud account team to learn more about Slurm on GCP. The next partner I'd like to highlight is NVIDIA. We are proud to offer 5 GPU families on GCP, with a new GPU family, the A100s, coming soon. On Google Cloud Marketplace, we have 50 plus NVIDIA Google Cloud, or NGC, containers available, and 600 plus GPU accelerated HPC applications. Also for HPC, NVIDIA has recently released an SDK that supports GPU accelerated HPC modeling and simulation applications. You can learn more about our partnership with NVIDIA, including how we're enabling industry-specific use cases at thepowerof2.solutions. Last but not least, you can find sessions presented by Googlers at GTC 2020 at the short link on the slide. We set up our GPUs in pass-through mode so that you can experience bare metal performance. And with the flexibility of cloud, you can attach up to 8 GPUs to your instance and mix and match different Google Cloud resources to build your tailored infrastructure. And of course, our typical features apply. You can preempt a GPU and take advantage of per-second billing and sustained use discounts. Google Cloud offers a range of NVIDIA GPUs, whether you need cost-effective inference or scale-up or scale-out training. As I mentioned earlier, we have a suite of 5 GPUs available today. K80 started machine learning training workloads years ago. P100, V100 are top-of-the-line GPUs for high-end training. P4 and T4 are great for inference. Did you know that we were the first hyperscale cloud to launch with these GPUs? We are also the only public cloud that has T4 GPUs available globally. We're also excited to announce forthcoming support for the new NVIDIA Ampere architecture and the NVIDIA A100 Tensor Core GPU. Next, I want to tell you about Rescale. Rescale offers an industry-leading HPC management platform that runs on public cloud infrastructure, solving the common challenges of implementing and managing cloud and on-premise HPC infrastructure resources in enterprise environments. At the end of last year, Rescale completed an integration of its platform with Google Cloud, and we launched a joint offering. Key segments that we are targeting with Rescale include electronic design automation, manufacturing, and healthcare and life sciences. You can learn more about Rescale on GCP at the link on the slide. Rescale offers a single portal that can manage all of your HPC applications and data. The portal runs on top of Google Cloud infrastructure, allowing you to quickly ramp up your consumption. Rescale's portfolio features 400 plus leading HPC applications and provides extensive coverage of critical workloads for aerospace, automotive, industrial manufacturing, semiconductor, and energy sectors. Customers can take advantage of Rescale's focused solution for HPC combined with the customizable, practically limitless infrastructure of Google Cloud. Rescale has years of experience partnering with software and hardware providers to pursue HPC workloads and enterprise accounts with its direct sales force. It also has a team of HPC hardware and software experts ready to assist you in accelerating migration of your workflows to the cloud. Again, you can learn more about Rescale on GCP today at rescale.com/GCP. Last but not least, I'd like to highlight one of our storage partners that focuses on HPC workloads, DDN. DDN has an offering available on our Google Cloud Marketplace called Exascaler Cloud. Exascaler Cloud is a scalable parallel file system purpose-built for AI, HPC, and other big data workloads. Ideally suited for dynamic pay-as-you-go applications, from rapid simulation and prototyping to cloud-bursting peak HPC workloads. Exascaler Cloud helps maximize storage performance and cost-effectiveness with GCP. The Marketplace offering also features 24/7 support. To learn more, you can visit our Marketplace today or contact cloud@ddn.com. As I shared at the top of the session, if there's one thing we want you to walk away with, it's this. Google Cloud democratizes HPC, and we want to enable HPC the Google way through our partnerships and product portfolio. If you'd like to learn more about our HPC products and partnerships, here are recommendations for related sessions to help augment your understanding. Thank you for your time and attention. We really appreciate it.